Hello everyone, good morning, good afternoon and good evening. Welcome to technical session 5E. Myself, Deepika Jain, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GIA Scholastic LLP, it is my great pleasure to welcome you to the ICICT conference on it. One second, no? Sorry for the interruption. Sorry, very sorry. Yeah, I would like to start from beginning. Hello, everyone. Good morning, good afternoon, and good evening. Dear authors and invited guests, welcome to Technical Session 5V. This session would be moderated by me. On behalf of Global Knowledge Research Foundation and GIA Scholastic LLP, it is my great pleasure to welcome you to the 10th International Congress on Information and Communication Technology, ICICT 2025, London, United Kingdom. The 10th edition of the conference has been organized in a hybrid mode. The physical event was held yesterday in London, and the virtual event is being held through Zoom, that is from 19th to 21st February 2025. I hope you will enjoy the knowledgeable sessions throughout the day. In this session, we have 8 presentations and each presenter will be given 12 minutes for their presentation and 3 minutes for question and answers. On 10 minutes, I will be raising a gentle reminder. I also request all the participants to stay connected with us till the closing remarks. And if you have any query or update, you can write to me in the chat box. Just before we start the session, I would like to introduce to our session chair, Dr. Priyanka Verma. She is an experienced educator and trainer in the area of lecturing and technology with a track record of working in the higher education industry, skilled in computer networking, Microsoft Excel, communication skills, leadership skills, creative thinking, teamwork, critical analysis, and problem solving. Currently, she is working as an assistant professor since 2015 to till date. Also, she is doing a part-time research on data science. Thank you, ma'am. I welcome you here. We also have another session chair with us. He is and Dr. Ibizil Abdul Qadir is an associate professor in informatics engineering, Faculty of Engineering, Islamic University of Riau, Indonesia. He is a senior member of IEEE and a member of ACM. His research interests are in software quality, models and architectures, software measurements, information systems, software engineering, and machine learning. I welcome you, sir.
Yes, thank you. Yeah.
Thank you, sir. Thank you. Okay, so we would like to begin with our first presentation. Give me a moment, please. We have our first presenter with us who would be presenting a paper on Alzheimer diagnosis through advanced deep learning architectures and interpretative analysis of predictions. George Lituma, are you here?
Yes. Can you hear me?
Yes, sir, I can hear you. You can start sharing your screen, please.
Okay. Can you see my screen?
Yes, I can see your screen.
Okay. Good afternoon, everyone. My name is Jorge Litoma, and I am the presenter or researcher today. This work was conducted in collaboration with Antonio Moy and Remy Hurtado, and my person, Jorge Litoma, from the Universidad Politécnica Salesiana from Ecuador. The title of the paper is Alzheimer Diagnosis Through Advanced Deep Learning Architectures and Interpretive Type Analysis of Predictions. Um, I will cover the content with introduction, related work, proposed method, design of experiments, results and discussions, conclusions and references. In this case, the Alzheimer is the one of the main causes of dementia and represents global health challenge affecting million people. And the early detection is more important for improve the quality of the life of the patients. And the techniques of machine learning and deep learning offer many opportunities for solve these problems and improves the patient's quality of the life. And solution has integrated gradients for the explain the predictions um, of the model of the proposal method. Um, with the advances of artificial intelligence, the research is made to the introduction of new solutions. We use a public dataset. This dataset contains 40,000 images um, distributed among 4 classes. Other point is the computer vision technique named CLAE and the training process with deep learning. We mentioned on the paper and some of the related works. In this case, for example, in 2024, the neural networks of the computing tomographers, hyperparameter tuning with the 97.39% of accuracy. This is a sample. Another sample is the transfer learning pre-training models with the 3 models and with this accuracy. Other related work is the CLAE plus UNET for the optimal diagnosis and improves the tomographies, radiographs for the better results, the model. And the other point is the introduced gradients. This is more important for the explain the predictions. The proposed method is the proposed method has 5 stages. The one stage is image extraction. In this case, the dataset contains 40,000 images distributed in 4 classes. 4 classes is the non-demented, very mild demented, and moderate demented. And the second point is the data preparation. We decide apply the grayscale conversation in each images and the resizing to 224 by 224 and the applying the computer vision technical. In this case, is CLAE. It will explain later. And after the training. In this case, we decided training 3 models: Super Vectoral Machine, BGG16 Extended, and Vision Transformer. The BGG16 Extended is the winner model, is the best model, and in the 4-pointed evolution of prediction and results. The results from the model, the winner model, VGG16, and the interpretations on results using the integrated gradients, using the best model. The winner model, in this case, the VGG16, we decide added to extra layers, in this case, the global average pooling to the layer, 2 denser layers with 512 neurons and other dense layer with 256 neurons with the real activation. Batch normalization at 0.3 dropout to avoid overfitting, and the softmax output for the prediction of the 4 classes. And the design of experiments. This is the graph of the class distribution. So the non-demented is the largest class, and the moderate demented is the smallest class in this four classes. And the other point is the applying the filter CLAE. What is CLAE? CLAE is the contrast limit adaptive histogram equalization. And this computer vision technical is very important because this filter improves the details of the images. And as you can see in this image has more details than this image because this model augmented the contrast, the images, and the model's training is better using this filter. The quality metrics in this case for we evaluate the best method is using accuracy, precision, recall, and if one score, and we decide with this we decide the best model among the models SVM, super vectoral machine, vision transformer, or BGG16 extended. And the other point is the validation method. In this case, this diagram illustrates the cross-validation. It's a technique used to evaluate the model's performance. And the performance metrics include the accuracy reminded about avoid 0.99 in all iterations, in this case 10 iterations, and in this way we confirmed the model's effectiveness. In this case, the BGG16 extended is the best model because the model correctly classifies and the other models the other tested models as a vision transformer or SVM. Vision transformer was a model with the present overfitting. So the model didn't learn and the model memorize of the images and the model return the sum class, for example, non-demented, 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 and non-demented all the time. And the SVM model, super vectoral machine, is a model, is a simplest model, and the results is regular and no, this model incorrectly classifies. And this model, this is the other models. This is a confusion matrix for the best model. As you can see, is almost perfect. The model, and this is a comparative graph between our models, Vision Transformer, SVM, and BGG16 Extended, and the CNN and AlexNet from the other researchers, from the other papers, and and the last, the integral gradients. What is the integral gradients? The integral gradients, it serves to explain the predictions. Why the model predict the specific class, for example, very mild demented. Why the model predicts the specific class, moderate demented. So these integral gradients serve this, and as you can see in this image,
Dear presenter, you have 2 minutes left.
uh, I'm sorry?
You have 2 minutes left for the presentation, sir.
And two presenters. Yeah. Um, the integral gradient, in this case, the 1 point is living brain tissue, and the black and the white holes is dead tissue, and this is our interpretation because the model predicts the specific class, and this is other example, the model implemented with the black point less. And the conclusion is the developed model demonstrate high effectiveness, and the applying CLI for image processing significantly and images quality and boosted model performance. The use of intergradients provide interpretability and they help for doctors or neurologists so they can help people in the world. Thanks.
Hello.
Yes, sir. Any
Yeah.
question?
Yeah. I just want to know how many data set that you analyze for this case, and the data set is come from which hospital or institution. Maybe you, if you have data, maybe can show the data set.
I'm sorry, repeat me the question. I don't understand.
You are analyzing Alzheimer diagnostic. Use deep learning interpretative analytic. Then
Yes.
normally in analysis or a diagnosis, we need a data. So just want to know how many data set, how the variety, let's say male and female, in terms of age, how many data set, and those data you obtain or you get from, is it international or just from your country or Ecuador?
It is international. It's a data set. It's a public data set. Then we use the data set from Kegler, and we decide use the data set for contains 40,000 images, and we train the model using the data set and divide the data set in train, test, and validation.
So the how many the variety did you check the you get from online dataset from Kaggle?
Yes, Kegler.
Okay. How long how old the data? The which year? Is 2024, 2023, or 10 years back, 5 years back?
Um, I'm sorry, I don't understand.
I mean, you get the data. The normally data mentioned from which hospitals. So I don't see your data set. This images, yeah. They don't mention the detail. Just I mean, you get from the Kaggle just image or any
Mm,
detail.
There's the details. This is a data set. This is a public data set, and
Oh, I
we
see. Okay, you get
uh,
from public because public is done very privacy. They don't say specific content on the data, the image. Okay. All right. Thank you. Thank you.
Thank
thank you.
you. Thank you for your presentation. Thank you, sir. Okay, so moving on to the next presentation. We have our next presenter with us who would be presenting a paper on auto labeling of vessel trajectories for maritime downstream tasks. Yes, sir, are you here?
Yes, I'm here.
You can start sharing your screen, please.
Okay. Hello, can you see my screen?
Yes, yes, I can see your screen.
Okay. Please permit me to stand on already established protocol. My name is Douglas Amoke. I'm a PGR student at Newcastle University, United Kingdom. I'm here to present a paper titled Auto Labeling of Vessel Trajectory for Maritime Downstream Task. My co-authors are Yuchin Lee and Dr. Mosin Navik. This this research is conducted within the Intelligence Sensing and Communication Group, Newcastle University. In the UK, the target of this research work is to meet the increasing demand for security and surveillance, particularly in the maritime domain, to get practical solutions that will monitor vessel trajectory for civil and defense applications. However, to conduct this, to carry out this research, we have to adopt a data set named AIS data set. AIS means Automatic Identification System. Is a data set particularly for the maritime domain. Over here, the picture here depicts vessel trajectories that was captured within North Sea, is a blind port in the Newcastle. So I will move on to the next slide that specify the scope of this research. This research is conducted within the scope of the data set, the IS data set for the Newcastle data set and the New York port data set. We are going to use these two data sets to analyze our network, which we have proposed to solve this particular problem. Previously, vessel trajectories are manually labeled by ship captains and experts in the maritime domain, but that never solved the intending issue because it does not have the real information. This classification method does not contain the real vessel information to be able to clearly define the vessel trajectory. With the advancement of AI and the flourishing part of AI into the maritime domain, researchers tend to adopt machine learning models to process AIS data and make solution and create data set for these AI solutions. But over the years, the researchers have been able to provide data set that does not have sufficient information to do this classification.
Excuse me. Sorry, I don't see your slides.
Okay. Is any
Just
other
now is
person?
the now is no slide, no PowerPoint. In earlier, you saw the slide. Can you
Is there
show?
any other one?
I see the slide.
You see the slide?
Yes.
All right. Okay, let me check. Go ahead. Thank you.
Is there any other person having the same issue?
No,
Yeah,
sir, you can continue now.
Okay, I can continue.
Yes, please.
Okay.
Yes, sir, please start.
I'm also
You're right now at the labels and data set slide.
okay. Can you see my screen now?
Yeah, I can see your screen.
Okay. Okay. Sorry for the interruption. I was trying to establish our boundary for the research, and our boundary remains within Newcastle port dataset and the New York port dataset. So to carry out this research, we propose a framework that's made up of 3 modules. The first module is talking about the dataset acquisition, and we stated how we actually acquired the 2 datasets we used. One of the datasets is the New York dataset is already decrypted, so we did not need to decrypt it again. If you have a look at this framework, the upper part that signifies the decrypted raw AIS dataset is going into the processing module right away, and the second dataset is the AIS dataset from the Newcastle port, is passing the encoder and decoder processes, because raw data AIS datasets are being encoded in ASCII code, so we need to decrypt it in order to proceed with the pre-processing steps. So over here is the pre-processing steps which undertook. The pre-processing steps are clearly mentioned in the paper. So we pass, after pre-processing, we did feature extraction to get the relevant information for the vessel trajectory labeling. Then this block explains the extraction process before feeding it into the network. Then this network does a lot of computation, uses some mathematical models to calculate distance, and relate the distance with the relate distance with the COG. These are one of the features which are in the AIS dataset. Why do we need this COG? COG is cost over ground, is a parameter that defines a vessel direction. So we use this direction to associate with the speed, because speed alone is speed alone cannot give us a clear definition of the vessel movement. So with the association of the direction makes the speed a vector, clearly giving us what with the direction of the speed and the magnitude. So the COG, which is the cost over ground, is the direction, while the speed is the magnitude. So these are the factors which we consider to develop this auto labeling network. Then the output of this network becomes an input to the classification model. We adopted the random forest model to do this classification. Then over here is the output of the classification model. Then how did we achieve this? We achieved this target by undergoing this methodology of study. First of all, we acquired the AIS data, and the pre-processed. Pre-processing is the second stage. Feature extraction makes our third step. Then the fourth step is the global feature computation. And this global feature computation is very necessary for this network, because that was one of the failures of other methods for vessel trajectory classification, because of similarities of so many features in the AIS data. But with this global feature computation, we were able to establish a uniform parameter which can able to separate and categorize every vessel no matter the location. Example, a vessel that is operating at New York port has coordinates of New York. a vessel that is operating in Newcastle port, it has coordinates of Newcastle. How will this network be able to classify and make unique classification, give it a unique label? So we used each of those geographical parameters, which is the latitude, longitude, linking it up with a heavy sign function to be able to derive the distance. Then with the distance, we computed the speed. Speed is a globalized parameter. So with speed is global. Someone that is moving 10 kilometers in Newcastle is still 10 kilometers in New York. And that is one of the peculiar feature about this network. So this global feature computation is what we use to be able to make this auto-labeling a globalized network to be able to adapt to any other network. Then the last step is the auto-labeling network that does these processes, which I earlier mentioned. And this is an example of the labeling process. This diagram figure 3 explains how the computed globalized feature is being associated with the COG, with a known COG and a known speed. After we computed the speed, we categorize the speed between 0 to 20 meter per second. This is already established in the literature. This speed limit is established in the literature, which we referenced. The COG is also established between 0 to 360 degrees, is also established range of value, and is being
Dear presenter, actually you just have 2 minutes left. Please conclude with the presentation if as soon as you can.
okay. Then after the classification, after generating this label by associating the speed and the COG, we were able to get 40 labels, which was clearly stated here, which is the output of this network. And these labels and the data was being fed into a classification model. Random forest model is the model we use in doing this classification. And we're able to get this precision, this classification results, the precision, recall, F1 score, and accuracy. So from this result, we notice that there is an overall strong performances within the three data sets. So the performances shows that the New York data set performed better out of the three, and the NCL performed least. Reason we attribute it maybe because there are challenging features within the Newcastle data set, and this is the confusion matrix for the New York data set that is showing strong performances of each of the labels being classified, but there is also misclassified labels. Like label 1 is being misclassified as label 2, and also this also happened in the Newcastle data set, where label 2 is also misclassified with label 4, and the third data set also had some misclassification, which we attribute this as overlap of features between the features we use in training this model. Then in the conclusion, we are able to understand that features from the AIS data set contains relevant information for vessel trajectory classification. It is able to use the features in each of the data set to be able to make predictions of particular vessel by showing a strong performances on the classification model. However, we hope to address some issues in the future research by trying to address the label overlap And we also like to look at adopting advanced model for this architecture, advanced model architecture to be able to solve some of these challenges which we encountered in this research. And finally, we want to make appreciation to our funding organization, TED Fund, that's Tertiary Education Trust Fund. It's a government of Nigeria that sponsors research for the tertiary, those in tertiary institution. I thank you all for giving me the time to make this presentation. If you have any question, I'll be happy to make some
Yes,
answers.
sir. Thank you
Thank
so
you.
much. Thank you. Any questions, sir and ma'am?
Let's say asking for Dr. Priyanka first. Is there any question from? If no, I just to confirm because you're arranging labeling on the vessels. So how you confirm the line or the trajectory of the vessels, and every day how many vessels crossing to the port? Is this you mentioned Newcastle port? Is it?
Okay.
Yeah.
That,
Every
that's
day
my second.
how many vessels go to the port, and how to verify to validate the automatic labeling?
Okay. Okay, thank you for the question.
Yeah.
Particularly, we used an open source AIS data for the New York port, and for the Newcastle port is a data set collected by Newcastle University, where I'm carrying out my research. So we looked at the messages, the AIS messages, and understand that there is a correlation in the vessel quantity, in the vessel traffic with season. So we chose August, around 2nd of August, for New York data to take record of our AIS data. So we got AIS messages of 2 million plus for 2 days data, which we used. We used the New York data 1st and 2nd of August 2024, and we have about 2 million plus AIS data. So I don't know if this answers your question.
Yeah. Normally the vessels, when they go to the port or the there is a guidance by pilot, then they follow the line or as you are automatic vessel. So how to validate the system that you generate automatic? So normally in manuals, the port officer will plot the line or the trajectory.
Yes.
So after your system is plotting the line,
Yes.
so how to validate this? The system need to validate automatic as well. This the correct line or the wrong line. So to confirm that your system is working well. So we cannot just pass to the system after the plotting, then we just leave it. No, we need to validate. Is it the system is give the correct answer? Do you have any something like to validate the system, your system, to check?
Okay.
Uh,
Thank you for.
yeah.
Okay. If I got your question right,
Yeah.
you are asking of how to validate what we have generated, what the auto label network has generated. Is that your question, please?
Yeah.
Okay. The challenge in the maritime domain currently is that there is no available pre-processed available data in the public domain. That's the major challenge. But however, we moved forward in processing our data using the MEMSI. MEMSI is MMSI, is an acronym for Maritime Mobile Service Identity. Every vessel has this number, and is unique to every vessel. So we use this to be able to aggregate every information concerning every vessel to be able to conduct this classification. So we are we can infer, and we believe that since we have used this particular vessel information and carry out this analysis, and it has followed scientific relationships, which we have noted in the paper, we believe that since it follows established scientific theories to compute all these features, we also believe that our output is correct.
I think what sir is trying to ask you is that whether
Okay.
you have worked practically with it. Have you implemented your system?
Okay. Sorry, I didn't get you clearly.
Have you implemented your system somewhere? This auto labeling, have you implemented it somewhere?
Yes, I've implemented it in Newcastle dataset and New York dataset. The output of this result is in the paper. The ID of this paper is 829. It has been implemented.
Can we now move further? Any questions and any other questions now?
Move forward.
Thank you.
Enough. I think enough. We go ahead for the next person.
Yes, sir.
Thank you.
Yes, sir. Thank you. So we have our next presenter with us who would be presenting a paper on development of a waste bank application with real-time monitoring dashboard for sustainable waste management. MS Hasibuan, are you here?
Yes, I'm here.
Yes, sir. Start sharing your screen, please.
Okay. You can see?
Yes, sir. Yes.
Yeah, okay. Thank you very much. Good evening. Assalamualaikum warahmatullahi wabarakatuh. I'm from Indonesia. Here, our paper, development a waste bank application with real-time monitoring dashboard for sustainable waste management. We have the four affiliation from IBI Dharma Jaya, Chonam University, Korea, and University Diponegoro and Telkom University. Okay, just to see about the Lampung. I'm in Indonesia in Sumatera. Okay, this is a background. The background about this paper is waste management has become a major issue in urban area. We collect from the Sorley et al. 2008 and how to reduce about the waste. And Waste Bank allow people to manage their waste to be exchanged in organic waste for money. So habit from the Indonesian people when the waste have waste and pull in the any place, I think. But we want to collect the waste and get the money. This is the idea. This is the background from the in the our village in waste can be burned and buried in the ground. And second, waste is collect from the bentor, you call the like the cycle, motorcycle, and put in the landfill. And another issue about the monitoring, how to monitoring about the waste in real time, because the government need the information about the how much to waste one day and a year and monthly and another. This is the problem because we have the place is not big. So this is a research method from the data collection. We have the data collection from the West Bank and the government. We collect an analytic and design the system for the monitoring and implementation, and we testing the system. This is a data collection from the West Bank. We have the organic and anorganic waste, and how to organic and unorganic to compare with the money, with the rupiah. We have the rupiah. It is to motivate people to collect waste and bring to waste bank and get the money. This information, and we get the first the table to design the information system application. We have the server and client to access. They have the subcategory. We have the login, home user, collector, admin for the user, and the description. You can see this about the how to user to be to collect the waste and to monitor and waste. And this is a ER diagram, and this is a West Bank application model, the collector model, and this is the application, and we can see the application. This have the how to pick up, where is the waste to pick up, and the people who to pick up the waste. We can get the 5-star, 4-star, 2-star, or 1-star. If 5-star, the people get to waste on time. 4-star, maybe not on time, late 2 hour, 3 hour, and when the one day they not get the waste, they have the no rating. This is monitoring for all the information about the system. We have the result, the application. They have passed to running. And conclusion: improve monitoring to collection scheduling, and enhance transparency in the collection process, real-time monitoring collection, and potential for expansion to large and region. Thank you very much. Any question, please?
I have a question. Has this app not been implemented before?
Yes, they have before. We not have the application to collect the waste. So this research, our research focus to get the application, to build the application, and to implementation in the one village.
So your main focus of this application is on the waste collection specifically,
Which collection, right?
right? And in specific areas or all the areas? I mean, have you focused on some specific areas or certain locations?
How to, sorry, can you repeat?
Your application is designed for waste collection, right?
Right.
Yeah. So this app, have you launched in certain specific areas to collect the waste?
Okay. For this for the research, we just to push in the one location in Lampung, but the API can get from the Google. We can use the another place in the world just to using the API. This, ma'am.
Okay, so it's public. That means anyone can use it.
Yes. any public can be used, and we have the register, and we validation the user, because the first is we have the one city, we call the one area for the pilot project, and this can be improved. The people collect and give to the bank waste, that is can be shared to another location. Thank you, ma'am.
Thank you, ma'am. Thank you, sir. Thank you. Thank you.
Thank you very much.
Thank you. So we have our next presenter with us who will be presenting a paper on digital innovation in MSME through Pentalix collaboration for tourist development. Yes, ma'am.
Yes, okay. Good morning. Okay. Can you see the presentation here?
Yes, yes, I can see your presentation.
Okay. Hello, everyone. Allow me to present the result of my research entitled Digital Innovation in MSMEs through Pentahelix Collaboration for Tourism Development with me, Farah Levita, Nurul Sukmalestari, Dendi Rosman from Binus University, and Dewi Andriani from Bosawa Polytechnic, Makassar. Okay. Can you see the presentation?
Yes,
Okay.
yes. Yes,
Micro,
ma'am.
small, and medium enterprises, or MSME, and tourism are closely linked, with each supporting the other. Their collaboration hold significant potential to boost the economy and regional development. Active collaboration between tourist destination and MSME is essential to support each other and improve the quality of tourism in Indonesia. This research examines how digital innovation and sustainable strategic affect MSME performance, with the pentahelix model acting as a moderating factor. For the background, tourism in Tangerang City, Indonesia contribute 30.53% of the total tourism in Banten province with 80 destinations. The city aims to boost its economy with supporting micro, small, and medium enterprises and encouraging interconnected business. And digital innovation is vital for the growth is MSME, aiding entrepreneurship, export, and job creation. Although MSME contribute over 50% of the Indonesian GDP, they face challenges such as limited capital, market access, and technology. Digital innovation can improve efficiency and address this issue. The pentahelix model, comprising academic, business, government, media, and community, can support MSME. This research explore how digital innovation and sustainable strategic affect MSME performance, with pentahelix as a moderating factor, and seek a solution to enhance MSME role in tourism and economic growth. For literature review, the performance of SMSA is shaped by both individual and group activity, helping them adapt to shifting market condition and consumer demand. The reflect of the economy vitally and adaptability of the business innovation play a key role in enhance MSME performance by enabling them to compete, grow, and sustain themselves. And then sustainability strategies are essential for MSME to maintain long-term viability and competitiveness. These strategies include online marketing, enhancing human resource quality, controlling innovating product, and collaborating with largest company. Research indicate that adopting sustainable practice has significant positive impact on MSME performance. Pentahelix is Indonesian model for socio-economic growth that bring together academic, business, community, government, and media. It focused on supporting innovation, encourage collaboration, improving performance, and promoting startup creativity through forum and skill development. Digital innovation and sustainability strategy both have a direct relationship in hypothesis H1 and H2 with MSME performance. H1 suggests that digital innovation significantly affect MSME performance. H2 suggests that sustainability strategy have a significant impact on MSME performance. Pentahelix, composed by government, industry, academia, society, and media, is placed in the middle. It acts as a moderating factor in the relationship, and H3 show that Pentahelix has a significant influence on MSME performance. In simple terms, Pentahelix have influenced the relationship between digital innovation and sustainability strategy on MSME performance. In this method, this research examined MSME in Tangerang City using a quantitative approach and snowball sampling. A survey was given to 303 respondents, focusing on their profile, challenge, and the variable being tested. The survey questionnaire was adapted from previous studies, including a statement on digital innovation, sustainability practice, collaboration, and MSME performance. And for that analysis, the survey showed that most MSME owners are women, aged 44 till 59 with a diploma level education, running business in the food and beverage sector. They have owned their business for 1 to 5 years and employ 1 or 2 people. Instagram is the main social media used for marketing. Most respondents reported earning less than 5 million rupiah per month, highlighting financial challenges for MSME. And for that analysis, before processing data with Smart PLS software, we check the validity and reliability by ensuring the loading factor is above 0.7 from that alpha, and composite reliability are above 0.7, and the average variance extracted is above 0.5. For measurement model, digital innovation, the item is strong measure that's variable and is very reliable. And sustainable strategy similar to digital innovation. And Pentahelix, the variable has very high reliability, and the item explain most the variance. In simple terms, this table show that the measurement model is reliable and its variable is well represented by its item, with all value with meeting the standard threshold for good measurement. And for result, the study found that digital innovation has a minor and insignificant impact on MSME performance. However, the sustainability strategy show a positive relationship. The third hypothesis demonstrate a strong positive influence. The Pentahelix model was found to moderate the impact of both digital innovation and sustainability strategy on MSME performance, with a statistic of 4.313 and 3.542 respectively. And the results explore the impact of digital innovation and sustainable strategy on the performance MSME. It found that digital innovation alone doesn't significant influence, and it's depend more on the business strategy and digital capability of the business. And the study also showed that sustainability strategy positively affect MSME performance by improving operational efficiency, customer loyalty, and brand reputation. And furthermore, the Pentahelix model, which involve government, industry, academia, society, and media, plays a moderating role in the relationship between digital innovating and sustainability strategy. The conclusion, the research investigate the impact of digital innovation and sustainable strategy on the performance MSME, with the Pentahelix acting as a moderating variable. The result indicate the MSME have a limited digital capability, highlighting the need for e-commerce training. Additionally, the studies show that sustainable strategy improve operational efficiency, customer loyalty, and brand reputation. Thank you.
Thank you, ma'am. Thank you. Any questions
Yes, Miss Farah, thank you for the presentation. So you are doing something like digital innovation for the MSME. So how many models digital that you are doing for the MSME? Did you check how the impact of the each model? Let's say you are doing promotion for the website promotion, social media. Do you check each model how much the impact after deployment? Uh, do you understand what my question?
Yeah,
Do you?
yeah.
Yeah, you
We don't check. We don't check
the impact.
the impact.
Did you do something like survey? How much the impact of the digital? Of course, many type of digital website, social media, browser, digital browser to the mobile phone, everything.
Yeah,
Yeah.
we only check the social media, but we don't check about the impact for the social media. Yeah, yeah, we just give a questionnaire and for check to measuring about the digital innovation.
Okay. Another one in this case, how many MSME did you apply? Only one MSME company, only one
No, 300.
100.
300, 303.
300, okay.
Yeah.
So yeah. Because we have done before similar like you for the our stage, so need to do something survey. So if there are some the model of the digital is not popular, so we can reduce. We go to further for the those only high impact like digital browser pop up on the email on the browser, something like that. Yeah. Okay. Thank you. Thank you.
Okay, we'll do in the another
What is that?
research. Thank you.
Thank you, sir. Ma'am, any questions? All right. We'll move further the next presentation. We have our next presenter who would be presenting the paper on integration of a solar powered Raspberry Pi system with an embedded TF light model for rice leaf disease detection. Yes, Anamnika Dhawan, are you here?
Yes, ma'am, I'm there.
Yes, ma'am. You can start sharing your screen, please.
Yeah, sure, ma'am. Okay, good morning, everyone. This is Professor Anamika. I'm from India. I will be presenting on my research paper that is integration of solar power Raspberry Pi system with an embedded TF light model for rice leaf disease detection. So here is the background of the paper. As we know that rice is a staple food in more than half of the world population, and it has been facing lots of like crisis due to some of the disease which it's faced. So globally, some I have focused on two diseases in this background of rice disease, that is the bacterial leaf blight BLB disease, which can alone can result in yield losses of 50%. Okay, and it is evidence that it has contributed to the Bengal famine in 1940s, okay, which led 90% of yield loss due to BLB, that is bacterial leaf blight. And this illness has reduced around the yield of 6 to 9% in Asia annually. There was the statement of UN on the World Population Day 2023 that the world population has reached around 1 billion over a span of hundred of thousands of years, and then it grew sevenfold. So the need of the rice has also increased according to the population increase. So there is a lot of requirement to do research in this topic in order to reduce the disease and to detect the basically to detect the rice disease in the early stage itself. So here is the aim and objective of the paper, where the key objectives are to detect the disease using the CNN, that is the custom convolutional neural network, where I reduce the model using TF-Lite into the TF-Lite format, that is a what you can say, a compressed version of model was created later in order to implemented on the some hardware constraint system like Raspberry Pi. Then the second thing is to introduce have a solar power integration along with the Raspberry Pi, so that the model or the system can be placed in the farms along, and it can work on its own, and it can have the power of solar. Then the next is IoT enabled monitoring. That is, the data can be sent, though this is future work, but IoT enabled monitoring so that the images can be captured. Then next is the scalable and cost effective deployment of the system for the farmers. So here is the literature review part, where I have been through this paper where the authors use the deep learning models algorithms like DenseNet 12, SE ResNet 50, and ResNet ST50, where they use ensemble model. Okay, and they use a voting system in order to find the disease in that particular image. They use the images of 33,000 uh, 26 images, where they had an accuracy of 91%. But the inference time, when it comes to usage of more than one algorithm of deep learning, the inference times become longer. So this is one of the drawback which I found in this paper. Then the next paper which I have been reviewed through was from Chain WA author, where he used CNN model, but he used real-time sensor data, but he had accuracy of around 89.4%. Here also the data accuracy was not much efficient, that much efficient as much required. Then in the next paper, that is the third paper of review, where they used the sensor and image data. They did this real-time deployment, but for real-time deployment of a dual branch model, okay, where they use cross attention mechanism, it requires lot of high computational resources, though they use 4,200 samples of real-time data. Then in the next paper, the CNN based IoT model again was used, where they had again accuracy of 89.4%. But as the CNN model was used with the component, IoT component, which are limited to some environmental variability, so that was one of the drawback. Then in the next paper, again a custom CNN were used, but they had an accuracy of 81.25%, where the data set was used was 120 images. So again, the loss of accuracy over here was found due to less amount of data which was used. Then one more paper which I had reviewed, where they used DCNN. They had a quite good amount of accuracy, but again they used images from lots of online sources, not just one source. They used multiple sources. But one of the main benefit which they had in this paper was they used some images where they did the expert annotation for the images. Then again, in one of the CNN model, where they use VGG16 model, where they achieved a very good accuracy, but VGG16 uh, along with CNN, it has high accuracy, but the parameter count was high, so it hindered the deployment on the IoT devices. So here is my proposed system, where the component which were used in my proposed system were Raspberry Pi 4 computer model B, where 8 GB RAM was there. It is Broadcom BCM271 processor. Then the next component which was used was solar panel SL130, which is a small, effective but a very effective solar power device that can be used conveniently by setting up. So it provides around 1.3 watt of power output at 7.5 volt DC. Then the next component which was used was battery. Okay, so Li-ion power battery, which was around of 32,000 mAh, which is very much portable, high capacity portable battery. So I use the solar panel to charge this battery, which can be provided to the Raspberry Pi, which will work along with the RPI camera module, which was a 5 megapixel. Uh, Here is the deep learning model. So this was the IoT system which was proposed, and here is on the right hand side, the actual implemented model is there, where I had did the hardware assembly of solar powered Raspberry Pi system. Then this is my deep learning model, which I applied on the data set which I got from Kaggle. So not from Kaggle actually, I got the data set from the IEEE data port, where I applied the data pre-processing first, that is rescaling, resizing, scaling, rotation, flipping, and zooming, where I divided the data into 80% for testing, 10% for, sorry, 80% for training, 10% for validation, and 10% for training, testing. So basically 80% training, 10% testing, 10% validation, where I did on that data I did the data processing, that is I did some data augmentation part, and later I did the model training by having these parameters, where initially I use con 2D and max pool 2D with kernel size of 7,7 and ReLU as the activation function. Then I at the end I repeated the same with different kernels, kernel value and filter value, and finally I applied the flattening layer and the dense layer, where the outputs were the classes of the two different diseases. So here is the result which I got on the Raspberry Pi. Though This is the theoretical description of the result, where according to our assessment, the original size of the model which was trained on the system was 5.06 MB, which was attaining the accuracy of 94.28% on the training data set. So after that, the model was created, which was of actual model, which was created of 5.06 MP. It was converted to the TF Lite model, that is float 16, where we got the accuracy of 91.18%. So specifically, there was not that much reasonable decrease in the accuracy when the model was converted. Actual model was decreased, model size was decreased from actual model to the TF Lite model. The batch size which I used for was 32, and the epochs were 250. Uh, and the conclusion and future work, though the model was compressed, it gave a very good amount of confidence or accuracy level, that is 91.18%. And but the limitation pertains to the environmental factors for live captured image. So to mitigate this problem, I will be having future work where actual the a component will be implemented in the field of rice, which will be here done in the Palghar area, which is in Thane, located in Maharashtra, India. So that's it from my part. for my paper. Thank you.
Yes, thank you for the presentation. You are professor?
Yes, sir.
Oh yeah, yeah. Sorry, just look like still young. Okay,
Yes, sir.
yeah, yeah. Okay, just to confirm, yeah. Uh, there is according to your title, you got mention integration of solar power for
Yes.
the Raspberry Pi. So, which part are you doing? So you are mentioned also on the last title for the rice leaf disease. Are you
Hmm.
focusing on the solar power or the disease of the rice field, rice leaf?
I am proposing the detection of two types of rice leaf disease, that is bacterial leaf blight and rice blast. These are two types of diseases. There are many, but I have chosen these two because they have caused lot of effect in the, or they have made lot of decrease in the crop, rice crop cultivation. And I have proposed this, I have built a system to be implemented in the rice field farm so that they can capture the images of rice field and they
Mm.
can detect the rice leaf disease live at that instance. And further in my future work I will be implementing it with the cloud, so that the live data can be captured and can be found at that time instance itself.
Yeah, yeah. I just a query because
Yeah.
in your slide, I don't see your if you are we are study on the disease of the leaf. Normally, it's
Yes.
showing the sample of the leaf with the disease, and then several leaf. What kind of the cause of the leaf is because of the end, because the another aspects. So we need to analyze with the grayscale and scaling
Yes.
how much the impact. Yeah, I don't see on your slide because you are uh, your figure or picture also mention solar power. So
Yes.
in the solar power, I think just for the power up the raspberry, this one just for the power up because you install at the remote area on the rice field need
Yes.
remote powering by solar panel. So next slide you are skip slide for number 8.
Slide number 8.
Yeah, yeah, 8. Yeah, yeah.
I will share
Next
again.
slide. Next slide. You just enter next slide.
Okay, next slide. Okay.
Yeah, this
Just
one also just bigger image from cable. Suppose you need data, primary data from the race field.
yes.
Yeah.
Yes, sir.
So yeah, you classify how many and the case by case. Okay.
Yeah, there were two types of data for which
Mm-hmm.
I classified. Like for two types of images, that is of bacterial leaf blight and leaf blast. Bacteria, sorry, blast, rice blast disease.
Mm-hmm.
Actually,
Yeah.
previously I did for four, so that's why it is showing for four different types of diseases. But I
Mm-hmm.
implemented for bacterial blight and blast.
Yeah, yeah, yeah. You need to so a bit detail, more detail, like scaling, resizing, and
Yeah,
but
yeah, scaling I did for
mm,
like by divided by 255. Then resizing, I resized the images to 256 by 256. Then rotation was done for 20% of the actual image. Then flipping was done vertically and horizontally. Again, it was done for 20%, and zooming was done for the images. That is, 10% zooming was done for the images.
yeah, yeah, yeah. Need to do detail, more detail, to classify the data, and finally we get the what the cause of the disease for the rice field or rice leaf. Thank you. Thank you for the presentation.
Yeah, thank you, sir.
Thank you, ma'am. Thank you, sir. Priyanka, ma'am, any questions?
I think no.
Okay, sir. Okay, so we'll move on to our next presentation. Presenting a paper on optimizing XGBoost hyperparameter selection with a modified meta-heuristic applications in IoT security. Alexander Petrovic is yes, sir. I cannot hear you.
Can you hear me now?
Yes, I can hear you.
Okay. Yeah, the physical mute switch was on.
Yes,
Thank you.
sir.
Yes. Once more, I am Alexander Petrovic, and I will be presenting the paper that has a really long title. And yeah, I didn't share the screen. Sorry, one moment. I don't see the share screen button here. Okay. Can you see my screen?
Yes, sir.
Okay. So yes, I will be presenting my paper, our paper, sorry, on the behalf of our colleagues that you can kindly read here. So not to waste time, I will move on to the paper itself. To introduce you to the topic itself, the main topic would be cybersecurity, because we have employed a public data set for DDoS detection in Internet of Things. So this is a very interesting topic because Internet of Things has a lot of, how would we say, limitations due to its hardware that it uses. And it can be extremely difficult to make a reliable cybersecurity approach for such networks. And they are susceptible to DDoS attacks due to this reason. And because of these limitations, traditional approaches are not providing significant enough results to be used in practice, because as well as the part of the cybersecurity defense is advancing, as well as the attackers' methods, and especially with employment of novel technologies. So our main approach is with the extreme gradient boosting algorithm, which is recognized as a powerful optimizer. So this has been chosen by the main predictor for this problem. So this technique detects the attacks themselves, but we also employ a meta-heuristic optimized algorithm. I apologize. The GA is something that was left behind. Please ignore this part. The Firefly algorithm is the optimizer used for hyperparameter selection of the XGBoost parameters for improving the performance on this particular data set. So a bit on background on the extreme gradient boosting. I will be brief here because a lot of papers have talked about this today. So basically, as I've said, it's used for detecting such intrusions and attacks. It is based on ensemble machine learning and decision trees. And besides that, it also employs the gradient tree boosting with regularization, which makes it more powerful than the random forest algorithm. And it's essentially its bigger brother, we could say. So don't take that fully at how would I say, at value, as I've said it. So the Firefly algorithm is a part of the bigger group of algorithms called swarm intelligence, and they are meta-heuristic approaches inspired by nature and principles from nature, or even some theoretical principles. And there are other meta-heuristics that are inspired by math, physics, and so on. But the field of swarm intelligence precisely is inspired by the swarm hive approach of problems where, as you can read from this slide, a lot of less capable units can complete a task that is difficult or impossible, rather, for them individually. It is interesting about this field that it has a lot of diverse goals and applications, and has been applied widely. Based for the Firefly algorithm here, once more, you can read on the slide that it is the optimizer for the XG boost. It belongs to this group of algorithms, and it is based on the communication of fireflies with light. So their main principle is that they have each firefly has an light emission of a certain intensity, and in the nature, the fireflies of lesser intensity, or rather lesser light intensity, are attracted to those that have higher light emissions. So the basic equations have been listed here for these principles. I will be not getting into details here on this. I would refer you to the main paper or main text of the paper. Once again, it's not SCA, it's a modified Firefly algorithm based on the island approach, where we split the population in two, and we also employ the quasi-reflective strategy of initialization, where the second half of the population are initialized as quasi-reflexive opposites of the first half of the population. And you can see this formula below the simplified pseudocode that is presented here. So the idea was to improve the earlier phases of the algorithm, improve its convergence speed, and as well overall performance, which I will shortly present as results follow. So let me see if I didn't mention anything from here, but as I said, it is a simplified version. It is yeah. Then there, I wouldn't add anything here on this slide. For the experimental setup, this is the name of the data set and the link where it can be downloaded. So for any extra details on the data set, I would refer you to this link, as get the information. And the upper and lower limits of the hyperparameters of the XG boost and those that have been optimized are shown here. So you can see on which values the optimization was based. As for the outcomes of the objective function, the island Firefly algorithm shows the best score on all categories here, except for the stability related metrics. And it is natural that the hyperbolic sine and cosine algorithm is slightly better here, as it is a strong math-based optimizer. But what was important to us was that the proposed solution was not outperformed by the original solution, confirming the made improvements. We also employed an indicator function, which was based on error rate. So once more, these results confirm the objective function results from the previous slide. As for the detailed metrics, we have also recorded the precision, recall, and F1 score for the intrusion class. I could not fit this table here any better, so I will just zoom in here a bit for your convenience. And as you can see, in almost all categories, the proposed solution has outperformed everyone else except the PSO for the normal class precision and the macro average recall. The chimp optimization algorithm has also outperformed it on the recall score, but since this field requires a lot of trial and error and custom built solutions for every particular problem, this can be considered normal, as no single solution cannot fit all problems. The results of the hyperparameter optimization. So what you see here are the best models that have been created through this optimization, and the exact selections of the hyperparameters for the XGBoost by each optimizer that was employed in the research. On this slide, we can see on the left, the error box plot diagram and the objective convergence graphs. So on the right, the red dotted line is the proposed solution, and on the left, the first box plot. So we can see that here there are slight differences between the SCHO, but as well as the previous result support, they don't seem like a significant difference, but it was outperformed by this other solution. To conclude, the best score that was attained was this number here, to not read the full decimal point, and the proposed model was validated through comparative analysis, confirming the possible improvements for the cybersecurity, and as well as for the original solution for this type of problem. And I think that I have maybe cut it short a minute or two, but this is all I have for you.
Thank you, sir. Any questions, sir?
Yes, just a simple question. Did you compare another other than XGBoost, how the performance? Just now you mentioned.
Yes, but
yeah.
Sorry, would you like to add something?
Yeah. Okay. Go ahead.
Okay, so the paper itself is based on XGBoost optimization. So that is we're trying to improve only this solution in this paper, but I understand why you're interested in that, and it is definitely a nice idea for another paper, but the research design would have to be completely different for, if I understood you correctly, for that type of experimentation. But it is something that we will certainly consider in the future.
No. Okay. Thank you.
Thank you for the question. Okay, is that all, or?
All right. We have come to the end of the presentation. I sincerely thank our authors for their excellent presentation and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for the support during the 10th version of the conference and all the previous 9th versions of the conference. We will be happy to see you in the 11th version as well. All the presenters will be getting their digital certificates through email within 2 working days. And all the papers have already forwarded the Springer board, and the publication will be live within 6 months. So kindly cooperate with the team of ICICT 2025. I also thank our session chair, Professor Afzal Abdul Qadir. Thank you for chairing the session, sir. This is a token of appreciation from the team of ICICT and Global Knowledge Research Foundation and the partners. Thank you so much, sir. And also, ma'am, thank you so much, ma'am, Priyanka Verma, ma'am. Thank you for chairing this session. It was great to have you both at this platform. Thank you so much.
Yes, thank you, Risha, for the moderator. As usual, I think for the fifth or the sixth, I am a session chair for this IC and ICT conference. Now for the 10, I think since 4 or 5 last time. Thank you so much for the invitation as a session chair. Although now, actually, I am not in Indonesia now. I'm in Tokyo. I have a collaboration meeting. So now almost 11. Yeah. All right. Thank you. All the best for the presenter.
Thank
And
you, sir. Thank you.
ya,
I
Pak
also
Said,
request
see you.
all the
Thank you.
participants to
Terima kasih
just
Pak
a moment,
Rizal.
sir.
Ya, makasih.
I just request all the participants to turn on their cameras for a quick snapshot, please. Thank you so much, everyone. Thank you.
Thank
Take
you
care,
for this
everyone. Stay
session.
safe.
Bye.
Thank you so much.
Thank
Thank
you.
you.
Bye.
Thank
Bye.
Take
you.
care.
Okay, bye.
Bye, sir. Bye, everyone. Thank you.